Greetings! Welcome back to the Old Ways Rising Farm YouTube channel. This is going to be the first of several videos on the topic of metal casting. And through these videos, we're going to do a deep dive in the process of how to actually do it. Now, our case study is going to be this little set of, see if I can get them all in my hands at once without dropping anything, this little set of duck and loon paperweights. Okay, these are the patterns that we're going to cast in bronze. And possibly other metals too. We'll see how it all goes. But while we're going to be playing with these little miniature duck decoys for the sample, I want to put this together in a way that will really show the process. Because there is a lot, let's just say, not the absolute highest quality information out there in the YouTube sphere and the internet sphere about metal casting. Okay, if you go and you watch some of the, shall we say, slightly sensational knife making shows, right? You'll see a lot of let's cast a bronze pommel, and then everybody utterly fails at it. Okay, I've seen other things, other areas where this is happening. And the problem is that pouring liquid metal exerts forces on your mold that are not really analogous to anything else you do in daily life. Okay? When you have your little thing, when this is finished bronze or aluminum or whatever we make it out of, and you put it on a surface, it just sits there, right? It has a certain mass, gravity has a certain pull, and it sits there, right? If it's really heavy, maybe it'll pull the surface down a little bit, but that's all it does. When that metal is molten, though, there's a lot more going on. You don't just have downward gravitational pressure. You have outward hydraulic pressure. Okay? And because metal is far denser than water, you also have that outward pressure being more forceful than an equivalent volume of water. So it's trying to blow your mold apart from the sides. Plus, metal is dense, and most of the materials that we make molds out of are less dense than metal. So you have the mold itself being more buoyant on the metal. And then the residual metal coming down, the pouring gates and the sprue and the risers and all of that structure is combining with the metal in the mold and the buoyancy of the sand that's on top of it to try and blow your mold apart from the bottom up. So when you're pouring this, you literally have forces in every direction that you're not generating with any other activity that you're likely to engage in. On top of that, you have gases. The gases have to do something. So the gases in the mold cavity itself have to be able to get out. Most folks know that. But the mold itself can generate gases. If you're using a Petrobond sand, it's going to vaporize. If you're using a green sand, you're going to have water vapor. And please don't ever do a lost wax or lost styrofoam casting where you leave the mold in, the part in, and try to depend on the metal to burn it out. Don't ever do that. But if you do that, that makes a whole bunch of combustion gases, which are trying to push the metal back out where it came from. Okay? So there's a lot going on when you're talking about metal casting. It's much, much more dangerous than forging. Okay? It's much more dangerous forging. Forging, if you drop something on your shoe, you're going to make a little stinky smoke as it burns or chars the leather a bit. Molten metal, if you drop it on your shoe, it's going to get in and start eating holes in your foot. There are more safety concerns. And remember, it's trying to blow your mold apart the whole time it's sitting there. It's going to take 2 to 4 minutes, depending on the size of the mold and the metal that you're working with, to fully solidify. That whole 2 to 4 minutes, it's trying to blow your mold apart. If it does, the tinsel fairy goes everywhere, and she's mean and sets stuff on fire, including your toes. Mm-hmm. So, I want to start with the series really talking about making a good flask to hold that sand. Talking about this is going to give us a good jumping off point to start understanding some of what's going on. Now, the flask. This is just to go over a little bit of terminology here before we get too deep into this. The flask is the container which will hold your mold. Okay? And then the mold is the material which will shape the metal as it flows into it. So the two that you're going to encounter as a hobbyist are sand casting and investment casting. Sand casting is what it sounds like. You're taking either green sand or Petrobond. Both of those are a mixture of sand with about 10 to 20%, depending on whose recipe you read, bentonite clay. And then either moistened with water to make green sand or moistened with an oil to make Petrobond. You can make both yourself if you want. That type of flask needs to be made in two parts because you need to have the piece, pack sand around it, flip it over, put the top on, pack sand around it again, pull it apart, remove the thing you're going to cast, your pattern, right? Put it back together, right? So you're assemble, disassemble, assemble, disassemble, assemble, disassemble. So you have to make that easy. You have to consider that in the design of your flask. Okay? And that's what we're going to be doing in this series. We're going to be talking about sand casting. Investment casting is a process where you pour plaster around your part, and then you're going to do a lost wax style casting, right? So you make your thing in some meltable material. Wax is the traditional, PLA is a modern version, and styrofoam is a modern version. And then you pour the plaster around it. In this case, the flask is usually just a metal pipe. A lot easier to do in that regard, but more difficult in some others, because then you need to melt the core, the part, the pattern out. And please, for the love of all that is good in the world, do that before you start pouring metal. Do not depend on pouring metal on top of your pattern to melt it out. You get a tremendous quantity of combustion gases which are trying to force the metal back out the hole, and you're virtually guaranteed, unless you are really, really, really good at mold design, which if you're watching this video and a hobbyist, you're probably not that good at mold design. If you are, make your own video. I want to watch you, okay? So those gases are going to lead to porous castings and improperly filled molds if you don't pre-melt your pattern, okay? But, like I said, we are doing the sand casting. That's where we're going to focus. The two parts to the mold are called the cope and the drag. The cope is the top, the drag is the bottom. You can think of like dragging the bottom around on your workbench, right? Cope and drag. If you have a three-piece flask, which you can do for certain casting styles, then the middle part is called a cheek. So it's cope, cheek, drag, or just cope, drag. You can just go and buy these, but they're fairly expensive. Actually, they're very expensive to purchase cast iron flasks. And there's no need to, because they're very easy to make from wood. But we need to talk about the wood choice. Like I said, casting is complicated. There is a lot to go into doing it if you want to do it right. The prohibition. Do not, I repeat, do not, I repeat, do not use pine or any softwood. Okay? Pine resins are so profoundly flammable. During the days of the wooden sailing ship, they used them as a primitive napalm to burn other people's ships up in naval combat. The same thing will happen. If you have a pine box that you're going to pour metal in around, even the radiant heat from your crucible is going to be enough to ignite the pine and start it flaming up. It's going to be a bad day. Don't do it. You want a dense hardwood. Okay? My top recommendation, and I'm not a glass blower, but I know that this is what glass blowers use to equip their studios. Everything wood is cherry, black cherry, because it doesn't flame up. Okay? Yes, it makes good firewood if you put it in a fireplace, and it burns for a long period of time because it burns very slowly and doesn't flame up. That's good for our setting, because we're not going to try to burn it. Remember I said about hydraulic pressure and buoyancy, trying to blow the mold apart from the bottom towards the top? Like it wants to blow the top off the mold. To prevent that, we're going to put, you could put flagstones or hunks of cinder block on top just to hold the sand down. That will also act as something of a heat shield. You don't want to get metal on it, it will spall. But it will act as something as a heat shield against that radiant heat and partially protect our mold. But still, some metal's going to come up out of the top of the pour cup, run around the sand. Maybe it drips down the side, and we want to make sure that it doesn't immediately flame up and start burning our mold apart. Cherry won't do that. It'll scar. It'll leave a char mark, but it won't flame up and try to destroy itself just from that brief contact. Okay? Use cherry. Second choice would be the rest of the reasonably available, reasonably priced, but heavy, dense hardwoods, like maple, some of the hard birch, not the softer birches, oak, those sorts of woods, right? They'll all work pretty well for you. Ash you could use. Ash is more flammable than some of the others, but you could use it. It would still make a decent flask. Don't use the really soft hardwoods. Like, don't use basswood. Don't use tulip poplar. Don't use, like, quaking aspen or cottonwood or any of those sorts of woods. Again, they're just too flammable. But your heavy, dense hardwoods are pretty good. I would also say, not that I've tried a burn experiment with them, but like your really oily hardwoods, right, like teak and purple heart and stuff like that, I would say don't use. I don't know how combustible those oils are, and I just stay on the safe side. Of course, they're so expensive, you're probably not going to want to, so it's probably a moot statement. But choose your wood carefully. Okay? For the flask I'm going to make in this video, I'm going to be using cherry. We have a batch of low quality, rough cut cherry. I do recommend that you go and find a local sawmill and try to get rough cut for this project. It don't gotta be pretty. Right? It's gotta hold sand. It's a sandbox. Doesn't have to be pretty. So get some, tell them what you're doing. Tell them it doesn't need to be pretty. Get some boards that are mostly sapwood or have some cracks or some shakiness in them. And get some cheaper cherry. You should be able to do this project for about $1 a board foot if you're going right to a local bandsaw mill. If you don't have cherry in your area, then you're kind of stuck. But there might be something in your area that's well known to be a little bit more flame retardant. You could use that. Especially if you're in the tropics. I know there's some real heavy, pretty flame retardant woods down there. So still, you could very likely do this project working with a local sawyer. And then to size our box, you want to leave yourself lots of extra room. Remember, the metal is trying to smash your mold apart the whole time it's cooling. And that's multiple minutes of opportunity for it to do so. You need thick walls. Oil-bound or water-bound green sand, right? They're strong enough, but they don't have a really high tensile strength. You just need to know that. It's a feature, not a bug, right? If it's concrete, it's hard to smash apart and get our part out, right? So you want it to be soft. You want it to be easy to pack in. You want it to be easy to reuse. But all of those things mean that you need a lot of it, right? So you want to go wide and deep. Now, if we look at these, and let me just pick out, this is the biggest one, okay? This little loon with the fish in his mouth. If I just quickly put a ruler on this, it's about 10 inches long the whole way across, okay? I want to go at least 3 to 4 inches out in every dimension, okay? So if it's 10 inches long, I'm going to make an 18-inch long box, right? Make it a nice even 1.5 feet, right? And then it's going to be laying on its side, right? It is bilateral symmetry down this plane, so it's going to sit in its side like this. So if I put the ruler here, it's about 3 to 4 inches. Okay? I don't need a really accurate measurement here, I just need an approximation. Okay? So, if I make it 1 foot by 1.5 feet, I will more than accommodate the extra sand. Is that overkill? Yeah, but I've got more of these that I want to make. Right, some of them may be bigger. You certainly don't need that size box for this little dude, right? But, you know, with that size box, I could put 2 of these in. Okay. Also, you want to make sure you leave yourself room to make a good gate system, a good sprue hole, and a good riser system as part of your casting apparatus. So there's a lot more going on inside a sand mold than just the piece. And all of that comes in because the metal shrinks. Remember I said at the beginning of this little intro, you have to account for the gases leaving. You also have to account for the metal shrinking. Because when it shrinks, it'll pull a vacuum. And that can be just as destructive as air pockets. So the riser and the sprue are together going to allow for excess metal. So as your part shrinks, that metal can continue to flow in. And you'll see when you cast it, you'll pour, it'll come all the way up to the sprue hole. You'll twiddle your thumbs for about 10 seconds, then it'll start to slump down. That's the shrinkage. Okay? So you have to design for that. Making a good mold isn't just having a good pattern and a way to get metal to it. There's more to it. And that takes up extra space in the molding cavity. So we have to plan for all of that. And giving ourselves extra space, you know, like I'm doing like 1.5 by 1.5 for even a relatively small part. Okay? That gives us plenty of volume to work with. And then for depth, the boards that I have by happenstance are 1x5s. So I'll have a full 10-inch stack of sand, which is a lot. I don't need anywhere near that much. But it's the wood I have, so I'm just going to go with it. Okay? So I don't even need to measure the bottom. I know 10 inches is so much overkill, it's not even funny. So that'll be easy to work with in that regard. Now, let's dig into the project and start building our flask. So I have gone ahead and cut out the basic pieces. These are 1x5 rough cut cherry. I did run them through the surface planer once, just because there was a lot of cupping and dishing. Okay. These are older boards. This is from a stack of lumber that my family had rescued from a load of firewood logs, and I'm using the dregs at the bottom of the pile that was kind of the junky stuff that nobody wanted to make something nice out of. Okay. But it's 20 years old, 20 years seasoned and dry, 20 years in a barn. So we won't have undue expansion and contraction with this. At the same time, we are going to end up with a cross-grain joint with some of these little splines going, you know, reinforcing the corners, going grain this way, whereas the board is grain perpendicular to it. So you definitely want to be working with dry wood when you're doing this. Now, the pieces, the lengths here, these are 18 inches and these are 14 inches. That'll give me an 18 by 12 inside, approximately. Don't obsess over exactly what they are. Not worth your mental effort. Do obsess over making sure that all 8 pieces, this stack and the other stack that'll go on top of it for the cope, that they are all exactly the same length in those 2 positions. That's the important thing. If they're off by an inch, meh, you're sand casting. All that matters is that it's internally consistent. Now the joint we're going to do is we're going to take these splines. These are some ash scraps that I had sitting around. Just pulled them off of the sticker pile. And these are going to go in like this and get screwed from both directions. Now, the easiest way to get these splines set is to clamp them one at a time, focus on getting everything really straight and true. You want to make sure that the end edge is absolutely flush and that the ends of the spline are just a little bit shy of the sides of the box, because you do not want one of these sticking out too far. So when I cut these, I cut them one kerf too small, and that's deliberate. Okay. Now when you're screwing hardwoods, and you do want to attach these with screws, you cannot cheat on your pilot hole. Okay? If you try to drive these in without properly sized pilot holes, you're going to have nothing but misery. You can get away with a lot when you're working with softwoods because the screw can push wood out of the way. But hardwoods are hard. You want to make sure that your screw is going to stick up enough. These two are basically a tack just to get it in place. So I'd like another 1/2 inch of screw. But for this particular purpose, these will be just fine. Okay. And we do want to use mechanical fasteners whenever we're doing this sort of cross-grain joint like that. Mm-hmm. If you use glue, if you try to glue this down, this piece will expand this way, this will expand perpendicular. On a 5-inch piece like this, there is absolutely going to be enough expansion and contraction to bust out a glue joint. Okay? It's dead dry, it's equilibrated with our environment, but it will still move slightly with the seasons. So, you absolutely need to do a mechanical fastener. Now, I'm going to go get all these 4 on, and then we'll talk about assembling the box itself. So you can see we have these put in place, and our box is pretty nice and square. There's always a couple little imperfections, like this one side wants to nose in a little bit. So we're going to be mindful of that as we go through the rest of this assembly process. Just like in the first instance, I have some clamps holding things together, and I'm going to make sure that I get these corners really nice and square. And I'm going to go through, and this time I'm going to put one screw into the end grain of the board. Those don't hold well. Okay, end grain does not hold screws much at all. That's why we have this corner reinforcement. So I'm going to put 2 here and 2 here. So we're going to have 4 screws on each corner from this side. I'm not going to do them all at once. I'm going to make sure that everything is good and square in this one corner. Drill my pilot holes. Okay. And this time, since these are the main screws that are going to hold everything together here, I'm going to use some good 2-inch deck screws for these. Those first ones were mostly just for alignment. By the time all of this is said and done, I'm going to have so much overkill in the screw department. It's going to be totally fine. So I'm going to go around, and I'm going to do this one corner at a time, make sure everything is staying in alignment as I do that. It's going to take me a while. It's a bit fiddly, but you really want to get this stage right. So we have arrived at the first part of our box. This will be the drag. Now we need to make a cope. Same process, same everything, and I'll show you when we're ready to move on to attachments. So, I finished the larger box that I was showing you earlier on with the layout and the structure, and I also made this smaller one, which is 10 by 14 here. So this is a couple of size options. After making that larger one, I was like, oh my gosh, that's gargantuan. And this would be a very nice size for one of these, that size, or 2 of these, this size, right? And the larger box would be good for 2 of those. So it's all good. We're going to make some options. Now, the last thing I need to do is to put together a system by which we can close these and hold them together securely. Now, you have to do this because, remember, if you're casting some little doodad like this with this much sand, this will hold a healthy 70-80 pounds of sand in total. you're not going to have enough buoyancy from this much metal to push the whole thing apart. But if you're casting a larger piece that's close to its capacity, you will. So you always want to set these up such that you have a good way of holding the two parts of the box together. Just doing a little bit of layout, just kind of deciding where I want to start. Mark my lines a bit more. So I have two vertical lines here. We're going to use a turnbuckle on these to hold it together. Now I'm going to show two different ways to hold these down, a turnbuckle and then also a cabinet latch like that. This one, I use slightly scrubbier boards on this one than the first one. So the thicknesses are a little bit off. And there's just enough of a thickness difference between these two that this type of latch won't line up well. But the other one came out spot on. So I'm going to put the turnbuckle on this one and those latches on that one. Now, as we're looking at this, get this all kind of loosely assembled, we want to estimate how much space we need to leave. So I just put two vertical lines where I want to hang these, and I'm putting this, just holding the line there across the screw thread on this bolt eye. Just going to mark about where the bottom of that hook crosses. I'm going to take one of these eyes and go one more eye width down. Now, in doing this, I have this turnbuckle closed all the way. So that first little bit is just measuring where does it fall when it is closed all the way. Then I want to go down a little bit more than that, because if I put the eye in, so it's just perfect when it's closed all the way, I won't be able to manipulate it. So I want to make sure that it's mostly closed when it's tight, but I also need a little bit of room to be able to open it, put it in, and then close it back to that. So I'm moving down one eye width. Then I will just strike that line across, the handy dandy square. Okay. Now we drill a couple of holes. First two holes. How did I decide where to put those first two holes? I just decided that looked good. Remember, this needs to be internally consistent. It doesn't need to be any particular way. Okay. Now we're going to put these eyes in. And when you're using these... Wait, I need to not get ahead of myself. They get a washer. When you're using these bolt eyes, the perfect pilot bit is sized such that you can just sort of screw it in with loose tension, but you can't just shove it in easily with the palm of your hand. That's where you have the best friction. Okay. But when you hit that, you just tap it in with the hammer. Okay. Set them so that they're nice and vertical. They get another nut and washer in the back. Okay. I will tighten all of this stuff up later on. Just going to get it loosely together so that you can see where we're going with it. And I put my washers away prematurely. Sorry about that, folks. Same deal here on the bottom. Okay. Don't want to wreck my square, putting a hammer on it. Set those all up nice. Get the nuts and washer started. Because I do not want to lose parts. I'm not going to take the time to tighten them all the way because you know how to do that. Just have them on a couple of threads there. Now what we can do is we can take these, and I'm just attaching them here with these turnbuckles. These little, these little clevises. Okay. Now we can just open them up. Till they hook in. And then turn it back. And that'll pull it tight very securely. Now, if I was going to cast, I would probably, going the wrong way. After this is as tight as I can get it with my fingers, I would probably go just a little bit more pressure with a pair of pliers to make sure they're all tight. But that's not going anywhere, right? I can't even slide it sideways. Just barely if I'm really, really trying. So that is a very secure connection. These two on this side I put a little closer into the middle, and then these that I already had done a little bit farther out. So it's also kind of indexing so you can see where it's set up. Okay? So that's our turnbuckle connection. That'll hold them together quite nicely. Now, I'm going to set things back up, change drill bits, get it all ready to go, and we'll talk about putting the cabinet latches on. This is the second good option, are these sort of drawer catch latches. So these usually come with their own little screws. Now there's a special technique that you need to know to use these screws and make them work. You take them and you throw them away. And don't even think about using them. They're junk, they're garbage, ignore them. Yes, they match the color of your latch nice, but they're kind of trash. I hate those stupid little screws. Now, to set these, I just want to make sure that our two halves are lined up just perfectly. Just like the other box, I did the first two over there just so it would be a little bit more stable and easier to demonstrate. And we're going to set these right where we want them. And I'm going to draw the location of the holes, which is 5 holes. Okay. And then switch to the pilot bit. Now to get a good snap, you need a little bit of space between these. So right where those holes naturally fall, I'm going to go, I'm just going to drill about a pencil lead width high here. And then a pencil width low on the bottom set. Okay. Might as well switch this back over to the screw. Now you're saying to yourself, you threw away those screws. What screws is he going to use? Well, for all utilitarian work like this, I like to use my drywall screws. Okay? Now these will poke through ever so slightly, but that's okay. That's just a little extra friction holding that sand in there. I haven't decided on those turnbuckles. They poke through about not quite an inch. I haven't decided if I'm going to trim them a little bit. Is a little bit excessive, but I'll probably wait and see if it ever turns into a big deal. If it ever turns into a big deal, that's what the angle grinder's for. If it never turns into a big deal, well then it's not a big deal. Okay. And 2 for the bottom. And you know what? Things that aren't a big deal, they're not a big deal. Mm. Did you know that, beloved? Mm-hmm. Okay. These little screws just poking their noses out ever so little bit, definitely not a big deal. And there we go. Attached with a nice snap, and that'll hold it in nice and secure. Now, I have 2 more screws here that I just saw that I missed. Thank you for catching me on that if you spotted it before I said something. I'm going to put this other latch right about there. And this is the same idea as that one. Now, unlike hinges, these don't have to be absolutely perfectly straight square relative to each other. They just have to be lined up well enough that the screws aren't trying to tear the latch apart and that nothing's getting in the way when you need to work with it. Okay, so I will continue doing this, and let me put this other one back up here. I think you get the idea of how these are being constructed. So there we have our little one-day project building these here 2 boxes. I hope that you enjoyed this. I hope that you got something out of it and see a little bit about what goes into setting up for a sand casting operation. And please, if you're going to do this, take the time to make these right. Okay? You really need to make these right. If you don't, you are going to have nothing but trouble. And trouble with molten metal is big trouble. Okay? You want to make sure when you're doing these that they are held together with buckles, right? Of some sort. Can be either sort, doesn't matter. They need to be held together with some sort of buckle. It doesn't really matter which is the top and which is the bottom, which is the cope, which is the drag, right? At this stage anyway. So when you're doing this one I'm looking at as being upside down in its current orientation. Because if you look at these little pieces, oh no, I'm sorry. It is right. This is flush. Okay, so there's nothing sticking up above this edge. This is not. This has that little protuberance, right? So this is the cope, this is the drag, since I use this type of buckle. The reason is because when you're putting this on top of, either a match plate or a parting board, this surface is going to be down and needs to sit level with that board. Right? So you do need to think about that. You want to make sure it's good, secure joinery. You want to make sure that these are not, all wibble wobble. They can't be too big in terms of the casting. They can be too small. If they're too small, the sand will bust out and you will, again, have tinsel fairy problems. We don't want the tinsel fairy around. The only thing that can happen with them being too big is that they can get ungainly and difficult for you to carry, right? So this small one, this 10 by 14, is going to be about 80 pounds, completely full of sand with no airspace. Now obviously the bigger the casting, the more airspace, the less sand, the lighter it is. This big one, that's going to be more on the order of between, somewhere around 150 pounds, totally full. Now you're only going to handle one half at a time. You're very rarely going to pick up the whole ensemble. If you do, you can put it on a board with a handle and have 2 people each carry an end, right? That's totally legitimate. But you do want to think through how you're going to handle these. Metal is heavy, sand is heavy, everything that we're doing is heavy. The more sand, the better. Better insulation, better resiliency and strength of the mold, better everything. up to the point that you can no longer handle your own project. Okay, so you do want to keep those things in mind. Make these. Make a couple of these if you're going to do any casting. Please take the time to get good materials because this is a dangerous activity. You want to take the time to do it right. I hope this helps you see what, doing it right looks like in this context. If so, I would be most grateful if you gave the video a thumbs up, and I hope that you will be back next time as we continue. The next video in this series is going to relate to some activities such as we've got to prepare these little patterns. We need to paint them. We need to sand them absolutely smooth. We need to... Is it in view now? Down? In view? Good, yes. So we need to do a little bit more painting and finish sanding on these, coat them, make sure that they're good and non-stick so that we don't get anything sticking to the patterns. We need to prepare these. We need to make our sand, and we need to make a pattern board so that we can start to assemble our mold. So some of those other things are going to go into the next video or a couple of videos depending on how the time goes. I hope that you will join us for that. And I hope that you will like, share, and subscribe because we do some fun things here at Always Rising Farm. It still breaks my heart that we're doing utilitarian projects with Cherry.